Let's move it towards the back. Back to you, Michelle.
Please standing and welcome to have a seat. Do you want to have
Yeah, we can try to pass it.
I do not mind. Oh, I'm sorry. I'm sorry.
That's okay. Hi, everyone. Can you hear me? I have a pretty loud voice, but I'll use the microphone. Why not? Right? We have one. So, thank you everybody so much for taking the time out of your evening to join us today. We're absolutely honored to have you. You are currently at the Autodesk Technology Center in Boston. How many of you are familiar with the Autodesk Technology Centers? Okay, fantastic. That's you've already gone on a tour, so I think that also helped. So our Autodesk Technology Centers are spaces where we bring together academia, startups, and industry, and provide space, resources, and community for groups to innovate for the future of design, manufacturing, and construction. The future of design, for the future of manufacturing, there's a lot of things that are really meaningful to us. Technologies that can help manufacturing become more flexible, more automated, bring down the sort of barrier to entry for a lot of the manufacturing companies out there. And so we're really excited to be working with groups that you're going to meet today, as well as AMT and MT360, who are really opening the doors and really moving us into a new paradigm when it comes to manufacturing. So for those of you who are keen to also engage with our community, we do have a residency program. Our website, you can just Google it. We're autodesktechnologies.com/technology centers. And we do have an application online. Residencies can last anywhere from 2 weeks to a year. We're completely free. We take no IP. Those are the major things. The rest you can learn about on our website. I won't go into like a full-on sales pitch. What I'd like to do is pass it over to Travis.
Thank you very much. So welcome, guys. My name's Travis Egan. I'm the guy that sent you all those various emails over the course of the last couple of days, so I apologize for that. I'm with AMT. I'd first like to thank Autodesk for hosting us here in this great facility. We did this in San Francisco in November at another Autodesk facility, and they've been great at both of these meetups. So the whole purpose of this is for AMT, the Association for Manufacturing Technology, to make you all aware of sort of an initiative that we have that's around the convergence of manufacturing and technology. So, the digital transformation that's going on is affecting everything. Every day, everything around you, and it's having a huge impact on manufacturing and the opportunities in manufacturing. So we are trying to bring together sort of these disparate groups of people. So the manufacturers, the Midwest manufacturing, throughout the United States, the manufacturers with sort of the technology companies in the certain sectors like here in Boston and in Silicon Valley, as well as with the investment community to figure out what can happen when you bring all these folks together and they collide and create opportunities for new products, new services, new business models perhaps. So I hope that's why you guys are all here. We're doing this with a big event in May 12th through 14th, called MT360 in Silicon Valley. We invite you guys all to come. There's some information on that as well. AMT, Association for Manufacturing Technology. You hear that word association, it's kind of like, oh, these guys are kind of old school, like boring, dull, stodgy, old group. And I assure you that that's not what you get with the AMT. It's a bunch of really smart, passionate people that are mission-driven to help really push manufacturing technology forward. So that's our mission. That's what we're trying to do to try and help everybody in this room to build your businesses. And so thank you for coming and enjoy the program. So I'm going to pass it over to our moderator, AJ Perez.
I'm gonna start.
Thank you. So why don't you guys have a seat? So I'll briefly introduce myself, tell you a little bit about why I'm here, and then let the panelists do the same about themselves. So my name's AJ Perez. I'm currently the co-founder of Industrial ML. Give you a little bit of a quick background on myself. I came up from Florida to go to MIT as an undergrad, studied mechanical engineering, and then pursued a degree in advanced manufacturing, also in the Department of Mechanical Engineering. As I was finishing up that degree, I was moonlighting my first startup, which was called NBBOTS, New Balance Robotics Corporation. It's a 3D printing business based actually right up the street here at 12 Channel Street. After maybe 2.5 years of running NBBOTS, we spun out a second company, which is a metal 3D printing business called Digital Alloys, the inventors of jewel printing. And then at the end of 2017, NBBOTS was acquired by Cincinnati Incorporated, the machine tool manufacturer, the manufacturers of the BAM, the world's largest polymer 3D printer. I ran that business unit here for them for about 9 months, and then I left and founded Industrial ML, which is a company that's focused on applying machine learning to the industrial world. And with that, I'm going to let the panelists introduce themselves now. So Dave, you can go ahead.
Thanks, AJ. So my name is Dana Horvath. I'm a principal at UCAP Partners, which is a boutique investment bank based in Los Angeles with offices in the Bay Area and Boston. You're actually looking at the Boston office right now. It's a small office. I joined UCAP, UCAP works primarily with smaller companies in advanced manufacturing, 3D printing, materials, working to get them investment from strategic investors or to help them run an M&A process, working primarily with strategic acquirers as well. And before that, I worked at Los Research, a market research and consulting company focusing on 3D printing was my topic area, and got a technical background in inorganic chemistry. So, thanks, AJ.
Yeah, my pleasure. That was actually when I met Dave first, was at Lux.
I profiled this company. Ask him what I gave him later.
Hi, I'm Saul Laskarden. I work at Tulip. I do product management there. Tulip, we are a manufacturing app platform. We help manufacturers digitize their operations. So anything that a manufacturer is running on paper basically can be turned into an app using Tulip. And the big differentiator there is that you don't need to know how to code, so it really opens up digital transformation for people in the shop floor so they can really drive it, connect their machines, sensors, and create interfaces for their teams to interact and capture data from their operations.
Hi everyone, my name is Jonathan Lord. I'm a co-founder of Flux Marine. We're actually one of the resident teams downstairs in the Autodesk build space. At Flux Marine, we design, manufacture, and market zero emissions electric outboard boat motors. So those are electric outboards, anything from 15 to 150 horsepower. So those can go on fishing boats, sailing boats, kind of any boat you could imagine. We initially started the company back in college. So it started as independent research while we were undergraduates. We then graduated, we moved to the Mass Challenge actually next door, and we've now been in the build space here for about a year. They've been instrumental in our progress that we've made so far. We've now just recently completed one of our prototypes that can actually match and exceed the performance parameters of the gas engine. So we're now looking to begin the scaling up process and refine our manufacturing methods that we're using.
So in terms of form tonight, kind of how I plan on running things, I've got maybe 7 or 8 questions here that I plan on getting through. I plan on at the end opening it up to questions from the audience, but if in the middle you have a burning question that is maybe like a point of order or clarification about jargon or something like that, in the beginning or at that point, stop us and ask that question then. But if it's kind of a diversion from the line of questioning, just hold it until the end. All right? So with that, the first question is, what does it take to invent and commercialize manufacturing technology specifically in the age of Industry 4.0, so connected smart factories. And do we consider this a large departure from the innovation cycles of the past, or is it the same old thing, but with new paint on the house?
You guys have the mics.
I can think, I mean, it's a big question, right? I personally think that it's not that much different than ever before, right? Like you have new tech, but you know, beyond the buzzwords, beyond the new enabling technologies, in the end, a good business is solving some sort of real business problem. So whenever, you know, we see vendors, you know, advertising some sort of buzzword, a new, you know, blockchain for blah, 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 you know, sometimes it is adding value, but if it's not really focused on a user need, it's probably, you know, not really gonna go anywhere. And the same with our customers. So we see a lot of people interested in Industry 4.0 because they read it somewhere or because, you know, they know that they need to digitize. But when that interest isn't tied to a business objective, usually, you know, if they engage with us, it dies kind of at the pilot stage. It dies at the POC, you know, they call it, MT360 I think calls it POC purgatory. So, you know, you bring some technology to your line, you deploy it, you run for a year, and that's it. That's even if you show value, like they didn't know what it was tied to. So, you know, in our view, it's really about tying the technology to a problem and not trying to, you know, have a technology looking for a solution. It's not really looking for a problem. It's really starting from the problem and seeing how you can add the value. So that's kind of broadly speaking. And then what it takes to build a company in Industry 4.0, I think, is, you know, it's kind of an interesting space because you have tech, you have software, but then you have manufacturing, which is, you know, a very complex industry. Selling to a factory is not the same as selling to, you know, an office. It's very different. The people you're dealing with are not on their computers all day, so it's a very different type of persona, I guess. And then at the same time, you have the other issue, which is change management. So with Industry 4.0 specifically, even if you have champions within the companies that know and understand what this is, and usually you do because people, you know, everyone has a smartphone, and then you get to a factory and you need to deal with HMI from the 80s or the 90s or with paper. So people don't like that, people prefer a smartphone. So people get why they need to go to Industry 4.0, but really driving that change requires more than just, you know, buying a technology. It's really about changing the mindset. So.
Yes, and I totally agree with that. And I think in order to kind of truly develop a business in this new age of manufacturing, it's really necessary to kind of use the new tools that are made available to you to break down the problem that you're trying to take on to its core principles. And those are now more easily available to us with new advancements in software and hardware. And pairing those together will really allow you to kind of benefit from those advancements and make the most of them in general.
And to come back to the innovation cycle and how it's really changed, I think, you know, is it something that's new or is it something that is just the same old process for developing the next generation or the iterative cycle there for new products, new go-to-market strategies, what have you? I'd say that it's the same fundamentals, but going much faster now. So the iteration time frames are starting to drop significantly, and having, you know, certain barriers removed, like no longer needing to code to put together proper workflows for assembly, or working towards easier access to designing manufacturing software is now becoming more and more mainstream. And ultimately, I think once 3D printing starts to tie in a little more of the production component, now it's going to become a more complete workflow and one that iterates very quickly. How soon that happens remains to be seen, but I'd say the digital twin concept is something to be looked after, and we're starting to see some of the big software guys starting to do that. but I don't think we're quite there yet.
Cool. So, Saul, you said something that was, that kind of got my mind turning around education, right? You were talking about buy-in from people on the floor, buy-in from management. I'm going to put a pin in this question, but maybe come back to it later, related to organizational education, related to I-4 Minor. So the next question I have is, when solving manufacturing challenges, are there fundamental differences between software solutions and hardware solutions? And are all software solutions viable as major players within manufacturing? Let's reverse the order. Dayton, you go first.
You caught me off guard with that one. I'd say, if I had to focus it down,
Answer the second part of the question. Are all software businesses viable as a major player in manufacturing? Maybe.
Well, what do you mean by that? With software business is major?
Yeah, as a true, pure software player, can you stand on your own legs in the manufacturing business?
not a chance, in my opinion. The software companies need to have more than just parts and more than just software. I think in the next 3 to 5 years, the closing the feedback loop and connecting the various, segmented design steps and going from initial design through to a functioning prototype and then iterating on that. I can only imagine how many steps there are at larger organizations, especially if you have to outsource any component of that because you're not vertically integrated on the product side. You are outsourcing a design component or electronics, or there's even prototyping is potentially outsourced, and so tying that back together, the software companies can only do so much to lead you to that next step. And the digital twin, I think, it's a nice idea, but without the hardware component in there, I don't think they're going to get very far in terms of improving how you actually deliver something. Generative design is kind of the oddball exception there, I'd say, because you're not working with traditional manufacturing to any extent.
Great. Jonathan, what do you think?
Yeah, I actually kind of agree. I think that on their own they will struggle to kind of stand up and maintain their position, but I think they do certainly have intrinsic value to add to the hardware industry, and not necessarily just with the manufacturing, but also the full life cycle of the product. So back to your point, kind of the digital twin, both the feedback throughout the entire life will help by incorporating that information that you're getting, can add real performance benefits to whatever parameter you're working in. So we work in the marine industry, and we're starting to adopt the digital twin idea and parameters. So that kind of allows us to increase performance parameters and optimize for very certain special conditions and specialized conditions which we wouldn't necessarily otherwise know to optimize to without the use of digital twin.
So
Hold on one second. Quick show of hands. Everyone know what a digital twin is? Okay. You guys want to come up with a unified definition of digital twin? What does digital twin mean to each of you?
digital twin to me is the design, every aspect of a product in some sort of digital format, and that involves the design specifications, any safety margins, going through to how it's being manufactured, the data around the manufacturing process, and if it happens to be a smart part, dare I say that word, the data input from its use in the field. That's beginning to end for me.
Yeah, so you have your digital twin and your physical twin. So those two are kind of intrinsically connected. So the idea is that if you can run tests on your digital twin, you can then infer conclusions about how your physical twin will react. This is kind of incorporating and really moving forward to the new era of manufacturing, is that the feedback time to actually iterate on these tests is just hugely faster, and also you can run digital twins on far more complex parts because you don't need a huge number of sensors to be operated on your physical twin, because you can then instead just run simulations of those on your digital twins and then actually infer the same results. So they're both clarifying results that you kind of anticipated, as well as finding out new things which you may not have ever considered before.
Any other opinions on?
No, it's not.
Question on that. The digital twin would be each and every component coming off the line. So we're making hundreds of thousands of vanes for aircraft engines. Each one of those would have a digital twin, which would track its use, lifetime, operating conditions throughout its useful life.
That's the dream. However,
I
I
like
think I'd say the digital twin is more commonly seen today in more traditional manufacturing equipment, where they're just tracking some aspect or some sensors involved, and it's a function of uptime or predictive maintenance to a minor extent. Going part or ultimately product level or subassembly, however you want to characterize it, for the and digital twin of that, I'd say is much further down the road. But I wanted to actually get an example because I came across a composites company last year, and Jonathan, I think this might be relevant to you. They had integrated so they can do continuous fiber 3D printing, but what they had integrated was fiber optic cable as well as copper wire into a composite rudder for a boat application. And I was curious, is that something that will ultimately be beneficial from the data collection standpoint on what that rudder is doing in real-time applications, but also from the propulsion perspective?
Yeah, absolutely. As much as the rudder, it would also be the propeller. With the advancements with electric propulsion in general, within the marine industry, as context, there's been very little kind of innovation in the whole, what we call the lower unit, which is all the mechanical parts which is submerged below the water. If you look at the designs throughout the last 100 years or so, there's kind of been very little change. And there hasn't been really any push from the customer, despite the fact that they're very inefficient, they're unreliable, and they're just a huge source of headaches really for everyone. So by kind of incorporating this, the digital twin, a big thing is predictive maintenance. So you can run, you kind of know the life cycle, how it's going to be operated and under what conditions. So by incorporating this into it, you can then you can skip the unforeseen maintenance required, and actually kind of use the motor for why you anticipated and why you bought the motor in the first place.
Thank you. So now that we've defined digital twin, I'd like to go back to the question for you, Saul. And I think I know your answer, but are all software businesses, do they have room to be major players moving forward in the manufacturing game?
Yeah, I mean, I think I would think that maybe not today, but I think in the future, yes. I mean, because of this idea of digital twin, if eventually everyone, all the machine manufacturers, everyone eventually connects their stuff, down the road, then you could be pure play software. We are actually a kind of a weird mix. We're consider ourselves a software company, but we also make hardware. The reason we make hardware, honestly, we don't force our customers to use our hardware to connect. So we make a gateway and a Pictolite solution. The only reason we make it ourselves is because we couldn't find anything in the market that was kind of at a reasonable price point and easy to kind of connect to without having to pay like integrators and all that. But the dream is for other people to make their own gateways as well, and we actually are device agnostic. So we have a whole library in our website that we're kind of trying to create an open ecosystem, not force manufacturers to use a certain hardware or not, because in the end, every company is different, every factory we've visited is different. They know which machine they want to use, and we are not going to force them to change the way they operate. So, in that sense, I think today you still need the hardware component. If it's not out there, then you may need to manufacture it like we do. But I think down the road, it is going to be possible to be pure software. But having said that, if you're already embedded into the systems of the factory, if you're already talking to the machines, to sensors, if you already have that, I think it obviously gives you huge advantage as a company.
Great, thank you. So starting with the investment banker, how do you separate hype from reality in this space?
Go to a lot of conferences. Step one, get out there, talk to a lot of people, understand where they're at, where their head is at, and you start to get a pretty reasonable average. And then beyond that, start to compile, well, I like to go from a data first approach, so I put together a lot of lists of companies, how they position themselves, where they're at in terms of size, geographic focus, positioning in the value chain, potential partnerships. It's the analyst side of me speaking up a little too much, but I'd say the hype is something you need to drink the Kool-Aid enough to understand where the excitement is coming from, but then always be willing to ask enough questions to understand what informed that hype in the first place. And I'd say that's a good place to start, and be cautiously optimistic, because otherwise you don't have a lot to look up to.
Go ahead, Saul.
So my experience with this is we've done quite a few pitch competitions, at which point there's kind of 10 or so companies. Everyone goes up, has maybe 5 minutes to pitch, which really isn't that long to actually present the true value add of a company, or its kind of USP. So I think the easiest way to kind of break through the swathes of companies who are kind of promising far more than they could ever achieve is to kind of break it down, again, back to the original one, is just break it down to its core principles. I think that if you can find the underlying values and really ask the questions which they're not necessarily pushing you to ask, you can really kind of break it down to see whether actually they can kind of fulfill on what their promises are.
Yeah, I mean, I could talk more about from the point of view of the manufacturers, because it's a constituency we talk with the most. I have kind of a rule of thumb. It's like an inverse relationship between the number of like buzzwords in our website and like what it actually does. So it's like buzzword bingo if you go to like trade shows, just ask what the problem is that you're gonna solve with something. If they're promising, the silver bullet that will solve all your problems using, the latest AI, and like it's gonna be so good that you won't even need people because it's gonna be better than all your people and it's gonna be smarter. It's kind of like a self-help book in a way. It's promising you eternal life, and that doesn't exist. So so I don't know. I'm a bit more skeptical in that sense, but in the end, what I usually recommend people is ask to try the product before you use it and before you pay for it. If usually, most companies nowadays that are confident in the technology will have some sort of way of giving you access to it before having to commit, $500,000 to deploy the technology. So that's a good way. Trying it is always a good way to really see if there's substance beneath the marketing.
What does industrial ML stand for?
Industrial machine learning.
Tell us a little bit more about that.
No, I'm not going to ask questions here. So, I'm going to ask the next question now. Where do investors fit into this picture, and what are they looking for? And if there was an investor that was here, what should they know about manufacturing? Is there a specific, unique point of view that they should have investing in manufacturing companies, say, versus tech or medical companies?
Well, I'm pretty early on in the stage of manufacturing, so maybe you would be better.
You're the investor, so.
I'm not the investor, I just help. So I'd say whether or not to invest in a manufacturing company, if you take a financial approach to it, you're not going to come out with some of the best numbers compared to traditional software technology, especially given the software as a service model. That's kind of been what the Silicon Valley and even other hubs of venture capitalists and similar have lived off of for the better part of 15 years now. And we're starting to see plays into logistics and other things, but in terms of manufacturing, how do you convince an investor to get in, to take interest there? There's a side that comes from the business model. Are you doing the same thing that everybody has been doing for 10, 20, 50, 100 years before you? Or is there some way you are making this a compelling case to get a financial return? And I'd say if your company is looking to do hard tech and be venture backed, that's an interesting combination where you need to piggyback off of the existing infrastructure, existing technologies in some way where you can identify scale or go-to-market strategies. I mean, there's only a few ways to turn that dial in the world of 3D printing that I'm aware of, and some of the companies have already started doing it in earnest. I guess the one I'd touch on the most is hardware as a service. It's just leasing. This is not a novel concept in the broader financial world, but now it's being rebranded as HAAS, capital H, two lowercase a's, and then capital S, just like SaaS, software as a service. The idea of doing that, it allows for more recurring revenue over a longer time frame. It gives you more time to get a product perfected, allows you to prove yourself as a supplier, as a provider of manufacturing technology, equipment, software, whatever you're doing to support your manufacturing customers. But there has to be something interesting to the business model that I think would make it interesting financially, not just from a technical perspective. The strategics are another category, which I'll leave for later.
Do either of you have any thoughts on this?
I mean, in our case, we have some great investors. We have Sandeep from Vertex. He's like a electrical engineer PhD, I think. So he understands the physical world and what it takes to make semiconductors. Has experience in that area, so I think that's always helpful. I mean, as well as software and technology later on in Silicon Valley. So I think having a little bit of the exposure to manufacturing, but also understanding how tech works is useful. And we also have Dana Grayson, so she's obviously invested in every Industry 4.0 company out there, like that's Metal, Formlabs, Onshape. So she has very deep industry expertise on the technology side of the business as well, and also the manufacturing side by virtue of what her niche is. So I think it obviously helps to understand, that if you're selling to manufacturing, it's a different type of organization than if you're selling, pure B2B software to, and bank, right? It's different.
Yeah, I think in terms of kind of attracting investors as an up-and-coming manufacturing company, I think it's important to acknowledge and truly show that you kind of understand that just because an engineering problem has been solved and is widely done does not necessarily mean it's an easy problem to solve now for someone who's new to it. So I think you should really identify the points at which you're bringing the value. So certain areas along the supply chain that you can then bring value along through the manufacturing process rather than trying to tag along all other areas of the manufacturing line, and then just try and even that out with kind of this one area or a handful of areas which you're bringing value to. So I think it's important to kind of narrow your scope in terms of manufacturing because it's a complicated problem and it's pretty big.
So I'm being conscious of time. We have about 10 to 15 minutes left, and I have a few more questions, but I want to give you guys a chance to ask questions before I continue drilling into these. Are there any from the audience right now?
Yeah, once again. You guys have all talked at least a little bit about 3D printing. We're a heavy metal manufacturer. We do everything from aluminum to inconel and some high-end parts for jet engines and rocketry, along with other smaller components. We've been playing with 3D printing, but it is still an extremely expensive process compared to traditional subtractive manufacturing processes. Do you see that cost coming down dramatically for harder metals like an inconel or a high nickel allow it.
There is hope, but not in the next couple of years, I would say.
It's my digital twin answer, it's a long-term answer, not a short-term.
Well, you guys aren't in a hurry, are you? I mean,
We've been around for a while.
so the throughput number, which is not always published, and sometimes you need to ask, and then the sales engineer will give you 4 caveats as to what the assumptions were, and he might give you a number at the end of the day of cubic centimeters per hour or liters per hour if they're up to that scale. Especially talking about the high end on the metal side, it's an area that right now we're still in the tens to low hundreds of cubic centimeters per hour for printed parts. And there are some technologies that I'm aware of being incubated at various startups or at larger companies that are looking to do, at least for the laser powered bed fusion / direct metal laser sintering, specifically, that are going to claim 10x on the hundreds of cubic centimeters per hour to get into the range that you're seeing binder jetting, aka desktop metal, HP's metal jet fusion currently playing at, but there's obviously benefits on the part side. So I'd say not yet, but they're coming, and it's best to get in early because especially if you work in aerospace or medical, those are the places where it's going to be adopted first, and then maybe high-end automotive, a little bit of oil and gas, some of the other places where that turnaround and that throughput starts to really make sense.
I mean, I have a little bit of perspective on it. I know the moderator is not supposed to answer, but I started a couple of 3D printing companies, one in metal. So take this with a grain of salt with that in mind. The companies that are selling you their novel machine and their magic material, and their magic material is at 100 to 1,000x commodity prices, those are the processes that are never going to hit the manufacturing floor. What I think additive is doing, and they're getting in their own way to sell the story to investors, is, oh, if you buy my machine, then I show you this J-curve of each customer is going to buy a bunch of material from me, and therefore I'm going to make a bunch of money. Invest in me, Mr. Investor. That model doesn't actually fly on the factory floor when the CFO gets involved and says, no, I'll pay 3% above commodity prices. So I think the processes that rely on and use commodity materials, so things that use wire or even commodity powder, but there's really not too much in the powder space, but wire and sheet metal, I think those are going to be the additive processes that you'll see really make a dent dollar-wise and poundage-wise in the manufactured world first.
And just to add to that, the current metal 3D printing technology, primarily the laser-based systems, they're not even materials cost sensitive right now. That's why they can charge upwards of $300 to $500 per kilogram for Inconel or titanium. It's all about the depreciation of the system to date. And so there are startups like Digital Alloys that are working towards that without that depreciation being the deciding factor on the cost per part out the door.
The things we're experimenting with have internal structures that you can't make otherwise, so it creates some value that couldn't otherwise be created.
3D printing is tooling, investment casting, or some other fun things in there that you might be able to get close, but once again, no guarantees.
You know, this for me is a question of, what do we mean by 3D printing? Does 3D printing get into $30 billion? Is that an exciting win when manufactured goods are 14, 15 trillion annually? To me, that's not even scratching the surface of manufactured goods. 3D printing winning means to me, casting and forging losing half of their market share to 3D printing. And for that to happen, you have to get down to commodity pricing on the materials. And the model for investors today is printers and ink. And that printers and ink model isn't going to fly on the factory floor if you're trying to displace casting. Because all the big foundries, they don't buy the magic material from the magic new startup that's sitting in Massachusetts. They buy it from the cheapest supplier nearby that gets them the best price. And I think a lot of startups miss that in manufacturing. the realities of cost.
Yeah, we definitely see it as a niche application at this point, that there are some places where it makes sense, but not too many.
Great. Thank you for your questions. Anyone else? Or any other questions? Okay. So time for maybe one or two more, so I'll ask another one. Which university programs are generating relevant IP and how? Are there specific labs within the universities? And how should companies think about leveraging the work that's being done?
So as a company that started from undergraduate research, the undergraduate scene is much more favorable to the students than the graduates scene, for example. So the university, often universities at least, for the most part, as undergraduates, they don't choose to take intellectual property from the students. You can work into partnerships. So Princeton, for example, you can work with the university and they will file all your patents for you, but they will take some share of that IP. But once you go to the graduate level, given that you are paid and effectively an employee of the university, you sign away all your intellectual property as a student. But so I think some, on top of that, universities such as MIT have strong entrepreneurship programs, and I think that's one of the real values that universities can bring. They have a sea of people, professors, teachers, faculty, who have great experience within all different kinds of industry that you can kind of go into their offices free of charge, which is always nice as a and kind of leverage their knowledge. So I think by expanding the entrepreneurship programs, or just even approaching those entrepreneurship programs as outsiders, you can really get the kind of insider knowledge of what's going on at these universities, kind of what people are interested in, and various other topics.
Yeah, I don't know which one it creates the most, but we're a spin-off as well from MIT. So we started out as a media lab, and the ecosystem there was pretty good. Obviously within MIT, but in Boston, there's a lot of ties between MIT and industry. We work a lot with a lot of universities have some sort of industry liaison program. MIT's program is called ILP, the Industrial Liaison Program, and they help match companies with certain startups or researchers that are relevant. Having said that, as a manufacturer, there's also a grain of salt there that if it's at the research stage, it might not be something you can really leverage until later on, once it's out of the lab. But it's definitely worth, knowing what's coming.
And knowing what's coming, I think, is probably the hardest part, because the technology transfer offices, they've got a dozen different names for them. There's no single database you can go to look at what IP is available for license. You probably get a slightly better source of interesting technologies if you look at what startups are trying to spin out university tech, because there's also usually a co-inventor involved in that startup in one way or another, and so that might help. But then there's a whole startup that requires incubation, then you've got market dynamics that they're trying to go after, and it may not be beneficial from the large manufacturer's perspective of, hey, we just want the tech, or we want that freedom to operate in this new area that we've already been cooking up for a while, but some university guys might have done something very similar, and it could be valuable. So I'd say it is a very difficult thing to find how to get access to this information source, and it's ultimately down to the per university level. So if you know where your top engineers have graduated from in the last 5-10 years, start with their alma maters. Start looking and saying, hey, what tech transfer, what professors are doing interesting work there? The ones that especially are up and coming, the assistant professors, the associate professors, those are the ones you start with, because I'd say they've got something to prove rather than the tenured professors that probably already have more of those partnerships in place. So even doing a quick check of, get the all hands meeting for your business unit and just ask, so where would I go if I wanted to find some cool new tech or something that might be relevant to our core competencies, but not quite ready yet for prime time. Those are the questions I'd be asking.
Great, thank you. Thank you guys for the perspective. So we have time for one more question, and I would prefer it to come from the audience.
You put a pin in the question too from before.
I know it's related to education, but does anyone have any more questions?
If you got the pin in the education question, I'd love to hear about that one.
Okay, so the question related to education was Saul's comment around organizational buy-in and whether or not there's a disconnect between kind of the workers and management. And my question was, what role do you think education has played, will play, isn't playing, should play in this Industry 4.0 transition?
Yeah, that's a great question. I guess my comment was around change management in general, which really applies throughout the organization, not only at the shop floor level, it really applies everywhere. We find our champions most of the time are actually shop floor employees that get excited about it and bring us. So it's managing up sometimes, but sometimes it's also from the top down, right? So how do you get organizational buy-in even after you have a successful pilot or a successful POC? How do you replicate that? And I think that's when, at least we here in in different forums or with our customers, we're part of the World Economic Forum, so that's something they talk a lot about, and that most manufacturers around the world are worried is the so-called skills gap, right? So how do you bring Industry 4.0 technologies in? It's been around for a while. All this, enabling technologies have been around for a while, honestly.
Yeah.
Why have it not permeated into shop floors? And oftentimes it's because the skills haven't been there, and the reskilling hasn't really happened. So manufacturers say they're worried about this, but a lot of them don't even have a strategy around how do you give your employees the tools they need in order to to bring this to your shop floor. It can be, we've seen very creative initiatives. So some of our customers have body training programs where traditionally the body training program would be somebody with a lot of experience would be teaching a new employee how to do certain things. The body programs with Industry 4.0 oftentimes is the reverse. So you have the millennial teaching a veteran how to use certain technologies because they feel more comfortable with the technologies. Other companies that we're involved with, have dedicated time for their employees to go and learn new skills, or even invest in certain technologies that enable on-the-job training. Sometimes it's using Tulip, sometimes it's using other vendors, or even in person. But it's definitely something we see, and we're actually pretty involved in helping solve. So working in Massachusetts, for example, working with the MEPs to try to provide more training locally, but with our customers obviously as well. And then at the more international level, with World Economic Forum, we have a couple of initiatives to kind of collect and make available content for manufacturers throughout the organization to gain the skills that they need. Even from basics on Industry 4.0 to how to become an expert on 3D printing or building your own IoT-enabled apps and things like that online. Because the content, for the most part, is out there, right? It's about making it available and giving your people the space and the time to actually get the knowledge.
So, continuing that thought, would you advocate for kind of a Google-esque 80-20 policy? But not creativity, 20% learning?
Yeah, I think there's value. I don't know if it's always feasible, but there's definitely value, especially if it's tied to an objective that the company has, right? So I don't know if the 80-20 would be necessarily the right ratio. I mean, I would, if I could make the rules, maybe I would do 50-50 or something, but I don't. But we do see that there's value in it. Strategically, if you look at the turnover on manufacturing the workforce, a lot of the companies are looking at a future where a lot of this knowledge will be lost. So if they are not investing in transferring the skills and the tribal knowledge, capturing it, training the workers, they are facing real strategic threats. So it's not a nice to have, really, in my opinion. It's more about strategic.
the only thing you mentioned managing up and finding your champion on the shop floor very often. Would it make your job easier if that champion, when they took that up to their superiors, already had that predisposition towards Industry 4.0 in some way, where it's like, oh, I'm aware of this is something I've thought about, but I don't know how to put it in place on the shop floor. What's the first call I make? How do I get an independent angle to it? So I'm just curious, is that something that you think needs to happen more of? Is there sounding like shop floor first here?
Yeah, I mean, maybe it was misleading to use the managing up in the sense that sometimes sometimes it is kind of proving to somebody who's skeptical that, hey, you actually need new technologies because there's more efficient ways to do things. We do see that, and absolutely, if that boss would know more about Industry 4.0 and the benefits, and oftentimes it's a discussion around cloud versus on-premise. It's just a different mentality. So definitely that would help. Most times when we have the champion coming from the bottom up, they already have some sort of ROI that they can show, and it's not convincing the boss or a supervisor. Usually it's scaling this up beyond their successful line or factory into others, and it's not really a managing up. It's more of a change management in a new environment. So how do you get people to do things and to think in a new way? That's more what I was referring to. So if before you would do an audit with paper and that was fine, like how do you get people to start thinking about new ways to do the same old processes?
Great. Thank you guys very much. If you guys would join me, please, a round of applause.
Just to close things off, I really appreciate everyone coming. I really appreciate AJ, moderating, and to our panelists. It's really important to have sort of these thoughtful discussions and honest discussions about this stuff. There's a lot of opportunities to hear sales pitches and the hype that's going on around manufacturing and technology adoption and convergence, but to have an honest discussion and be able to ask questions is really important. And I believe in this sort of format of doing things. So I really appreciate you coming. Stick around and network with each other, because that's really the most important part of all this. Is I had a chance to meet most of you here, and you're all coming from different perspectives and will bring different values to the table and would really benefit from meeting one another. So have a drink, it's warm in here, have some food. We really appreciate you coming. Thank you.